Hello everyone, welcome back to our channel, The Ducking Stories. In our previous videos, we introduced you to Snowflake and explored its numerous advantages. Today, we're diving deeper into the fascinating world of Snowflake by taking a closer look at its architecture. Today, we are going to discuss about the Snowflake Architecture. Snowflake Architecture is an hybrid architecture which combines the features of shared disk architecture and shared nothing architecture. Let's discuss what is shared disk and shared nothing architecture in a simple terms. Shared disk architecture. In shared disk architecture, multiple nodes in a distributed system share a common disk storage. Each node can access and modify the data stored on the shared disk, allowing for high data availability and seamless data sharing among nodes. Shared nothing architecture. In shared nothing architecture, each node in a distributed system has its own dedicated resources, including storage and processing power. Nodes operate independently and do not share memory or disk resources. This architecture offers scalability and fault tolerance, as well as better performance for parallel processing tasks. Snowflake Architecture. The architecture of Snowflake is a hybrid approach that combines elements of shared disk architecture and shared nothing architecture. It separates the costs of computing and storage, allowing for better cost optimization. Additionally, it provides the flexibility to easily scale up or down the resources for storage and computation, based on the specific needs of the organization. Snowflake Architecture Layers. 1. Storage layer. Compression. The storage layer in Snowflake incorporates advanced compression techniques to optimize storage space and reduce data storage costs. By compressing the data, Snowflake can efficiently store and manage large volumes of data while minimizing storage requirements. Micro-partitioning. Snowflake utilizes a technique called micro-partitioning, where data is divided into smaller, more manageable units, called micro-partitions. Micro-partitioning allows for efficient data pruning and retrieval, enabling faster query performance by minimizing the amount of data accessed during query execution. Columnar store. Snowflake's storage layer employs a columnar store approach, where data is organized and stored column-wise rather than row-wise. This columnar storage format enhances query performance as it enables efficient data compression, better data compression ratios, and improved data access by reading only the required columns for a particular query. 2. Compute layer. Functionality of compute layer. 1. Query execution. The compute layer executes queries and processes data to retrieve insights and perform data transformations. 2. Virtual warehouses. Snowflake utilizes virtual warehouses, allowing users to scale compute resources up or down based on workload demands. 3. Concurrency and performance. The compute layer ensures high concurrency and performance by enabling parallel processing of queries across multiple compute clusters. 3. Services layer. Functionality of the services layer. 1. Metadata management. The services layer handles metadata, including table schemas, query history, and database structures, ensuring accurate data organization and management. 2. Query optimization. Snowflake's services layer optimizes query execution plans for efficient data retrieval and processing. 3. Security and access management. It provides authentication, access controls, and data governance mechanisms to ensure data security and compliance. 4. Transaction management. The services layer manages transactions to maintain data integrity and consistency. 5. Infrastructure management. It handles the underlying infrastructure, including resource allocation, fault tolerance, and monitoring, to ensure the smooth operation of Snowflake. The Snowflake architecture also includes additional components such as data sharing and multi-cluster architecture, which enhance data collaboration and enable parallel processing of large workloads. Make sure to hit the subscribe button to stay tuned as we take a deep dive into the intricacies of each layer in Snowflake's architecture. We'll break down and explain the storage layer, compute layer, and services layer in a way that is easy to understand. Don't miss out on this opportunity to enhance your knowledge about Snowflake's inner workings. If you're interested in hands-on live online training, feel free to reach out to me on Instagram at DataMonk7. I'll be glad to connect with you and provide you with the opportunity to learn Snowflake through interactive training sessions. Looking forward to connecting with you on Instagram?